Okay, here we go. So today we're proving triangles are congruent. So it's important to know the types of angles that you have because we're going to build from that. We're going to take those types of angles that we have and we're going to build from that. So we know that congruent polygons, this is just a definition, okay? So we know that why do your triangles, I'm a page ahead, I think. There we go. I'm like, what is going on? This is page 21. Okay, sorry. Yeah. Yeah, thank you. So congruent polygons, here's the definition. In two congruent polygons, all of the parts of the polygon are congruent to the corresponding, is it frozen? Sorry. Thank you. To the corresponding parts of the other polygon. These corresponding parts include angles. That is so crazy. I swear I didn't touch anything at all to change color. Angles and sides. Angles and sides. So you can actually tell the parts that correspond to each other by the name. You don't even need a picture. So triangle CAT is congruent to triangle DOG. So when we think about corresponding parts, it's written in the name. The first letter represents an angle, has to correspond to the first letter of the other shape. So angle C is congruent to angle D. Well, then that means that angle A is congruent to angle what? Say again. Angle A is congruent to angle O. And angle T is congruent to angle G. So if you think about the way this triangle is named, it goes from C to A to T. Kind of that's the way the arrow flows. And you have to follow that same pattern. So C corresponds with D, A corresponds with O, and T corresponds with G. But we don't just have angles that correspond to each other. We also have their sides. So you can still not even look at a picture, just look at the name of the triangle. So when I think about the sides, I know that segment CA, those are the first two letters, is congruent to segment DO. CA congruent to DO. Well, what are the next two letters? AT is congruent to OG. Segment AT is congruent to segment OG. AT, OG. Then the last pair of sides are going to be the first letter and the last letter. CT, first letter, last letter, is congruent to first letter, last letter. Segment DG. First letter, last letter, CT. First letter, last letter, DG. These markings that I put on the triangle tell you what the corresponding sides are. CA has one mark on it. It's congruent to DO. One mark. AT has two marks on it. It's congruent to OG. Two marks on it. CT has 3 marks. Congruent to DG. 3 marks. We can do the same with the angles. Angle C corresponds to angle D, so they're congruent to each other. Angle A is congruent to angle O. 2 lines at each angle are 2 arcs. And then angle T, three little arcs, is congruent to angle G. Okay. So these are all of the pieces. So where it says this means, that's what this is. This means that these are all of the corresponding parts that are congruent to each other. If you have two congruent polygons, their corresponding parts are congruent. Dylan, I want you to pick your head up and write some notes. It's not nap time. Okay. All right. So the definition of congruent triangles says that the corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. Well, that's a mouthful. Corresponding parts of congruent triangles are congruent. If you have to say that every time you're trying to say something about the angles of a triangle, so we use an abbreviation for that. We say C, P, C, T, C. Corresponding parts of congruent triangles are congruent. CPCTC. So I'm going to try to use at least 3 different colors pretty consistently. You guys might want, it might be better for you to have a couple of different colors out. I don't know how your brain works. My brain works in color. So this first example, this is written really tiny, so I'm going to write it bigger. It says triangle DEF is congruent to triangle KJI. We have to figure out how to finish this statement. The statement says that segment FD is congruent to something. Well, the first thing that I want you to do is don't even look at the pictures. Just look at the names. FD, that's the last and the first. The order that I named them was the last letter and the first letter, has to be congruent to what? What's the last letter and the first letter? IK. And I know you're thinking to yourself, Mrs. Bischoff, does it really matter? Yeah, it does, because if you have a shape that's bigger than 3 sides, it really does matter, okay? So just think of the way it's named. So now let's show that. Well, triangle DE has, or triangle DEF is congruent to triangle KJI. So DF, side DF corresponds with side KJ. That means they're congruent to each other. I don't know if the colors will help you. Side EF, that's the second 2 letters, corresponds with JI. And then the last, DF, corresponds with KI. So the colors that match are the congruent pairs of sides. But again, if you name your if they're named properly, you don't even have to look at a picture. You can just look at the way it's named. You can look at the way it's named. Okay. So let's look at the measures. So I don't know if you guys can see it, but you have an arc right here on J, angle J. You have 1 arc. Then you have 2 arcs for K and 3 little arcs at angle I. Do you guys see that? Draw those in. You have 1 at J, 2 at K, and 3 at I. But you also have 1 arc at T, 2 congruent arcs at R, and 3 arcs at S. So you can use the number of arcs to compare the corresponding sides. So T corresponds with J, meaning that angle T is congruent to J. Does that make sense? Because they each have one arc on them. One congruent arc. Do you guys see that? So this triangle that we're looking at is triangle IJK. And it is congruent to some triangle. Well, how many congruent arcs or congruent markings are on angle I? There are 3. So I have to find the angle from the other triangle that has 3 congruent markings. So that's angle what? S. Then the next angle that was named in this triangle is angle J. How many congruent markings does angle J have? 1. So I have to go to the triangle, the angle in the second triangle that has 1 marking on it. So T. And then the last angle is the one that we haven't touched yet, R. So triangle IJK is congruent to triangle TSR. That's how we name the angles that correspond. We have to match the congruency marks. Dakota, does that make sense? Okay, I want you guys, you're not putting your heads down. No more of this like heads down, you had a bad day. Trust me, I've had a bad day. We're getting it together and we're going to get through it. Okay. Does this idea make sense? Okay. So the next thing that we're going to do is we're just going to draw a triangle. And I pretty much draw the same stinking kind of triangle every time. My brain works in right triangles. I don't know why. So even if like the measurements that I put on there don't really make sense, I just draw it like this: triangle A, B, C, and triangle D, E, F. If I don't draw a right triangle, I have to really think hard about trying to make them look congruent. So those are my 2 triangles. And then it says, hey, just fill in the measurements that are given and see if you can solve for X and Y. So I know that segment AB equals 7. So I'm just going to put a number 7 over here. And I know that segment BC equals 9. And I know that segment AC is 11 plus X. Now, for those of you that like pictures, I always draw a picture, but sometimes my drawing doesn't fit like the measurements and I have to just, do you know what I mean? Like I'm just making a drawing. And so then once I figure out the value of X, sometimes the measurements don't always make sense. I just need the drawing to help me process. Okay. And then I'm going to go to segment DF, and it says segment DF is 3X minus 13. And segment DE is 2Y minus 5. Well, I know that AB, segment AB, that's the first 2 letters of the first triangle, have to correspond, meaning are congruent to the first 2 letters of the second triangle. So I know that AB is congruent to DE because of the way those triangles are named. So what is the measure of segment AB? Yeah, so 7 has to equal, what is the measure of DE? Yeah, so solve that. What am I going to do? Add 5 to both sides. So 12 equals 2y. Chandler, are you taking notes? Okay. Divide both sides by 2, and I find out that 6 equals y. So we've solved for y. Well, what else do I know? Well, I know that AC, the first and the last letter of the first triangle, has to correspond to DF, the first and the last letter. So that means that AC is congruent to DF. Well, what can I say about AC? What's the measure of AC? 11 plus X. And if they're congruent, that means their measures are equal. So 11 plus X has to equal, 3X minus 13. Subtract X from both sides and add 13 to both sides. So 24 equals 2x, which means that x equals what? Yeah. X equals 12. Thoughts? How could you check? Like, what if you're like, this, I don't know. How could I check this? Yeah, plug the numbers in. 11 plus x, well, that's 11 plus 12. What is 11 plus 12? 23, okay. And 3 times 12 is 36 minus 13. What's 36 minus 13? 23. Those sides are actually equal to each other. We did it right. Y is 6. That's 12. 2 times 6 is 12. Minus 5. What is 12 minus 5? 7. So you could plug in and check to make sure you got it right. Okay, you could plug in those numbers and check to make sure you got it right. The triangle that you drew is just a visual to help you label it, right? It's just kind of helping you parse it out, label it out. So triangle LMN, triangle RST. I don't know why, but I always make the right angle the first letter of the name. So LMN and RST. You can label it however you want as long as you label them corresponding, label it the same way, right? This one is telling us some things about the angle measures. So it says that the measure of angle L is 49 degrees. And the measure of angle M is 10y. And then it says the measure of angle S is 70 degrees. And the measure of angle T is 4x plus 9. What do you think? How would you go about solving this? What do you think, Dylan? What could you say about angle M? What is angle M congruent to? It's the second letter of the first triangle. Good job. Angle M is congruent to angle S. That means that their measures have to be the same. That means that 10y has to equal 70. So what does y equal? Y is 7. God bless you. Y is 7. Okay. Well, what do you know about angle L and angle R? Say it loud. Yeah, they're both 49. These are both 49 degrees. How are we going to solve for x? This is the theorem that we learned on Wednesday or Thursday. The triangle sum theorem. What do we know about the interior angles of the triangle? What do we know about all of these angles? If I were to add all of these up, what? They add up to 180. 70 plus 49 plus 4x plus 9 has to equal 180. All right. So 70 plus 49, 119 plus 4x plus 9 equals 180. 119 plus 9, well, that's 128 plus 4x equals 180. I could subtract 128 from both sides. And I find out that 4x equals 52. 4x equals 52. So what does x equal? Calculator bunnies, anyone? Yeah, x equals 13. What do you think about that? Does that make sense? Dakota, pick your head up. Yes or no? Makes sense? Okay. I'm moving on. Are we okay to move on, or do I need to keep that there for a second? Yeah. Quali, you good? Okay. All right. So when we think about proving triangles congruent, we have several theorems, but we're going to talk about two theorems or postulates. We're going to learn two rules today. So the first thing that we're going to talk about is, what is a postulate? A postulate is something in mathematics that is just understood or known to be true. So it's true without proof. So a postulate is something that is true without, I just put new batteries in here today. Can you tell? Neither can I. True without proof. It is true without proof. Sometimes this postulate is also called an axiom. Just so you know, that's another word for a postulate. It's just a math rule. It's kind of like just thinking of a math rule. You don't have to prove it. It's just true. So the first postulate that we're going to learn today is the side postulate, which we abbreviate SSS. And we say that if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So we use the side postulate. If three sides of one triangle are congruent to three sides of another triangle, then those two triangles are congruent. So in these examples, I labeled them because I need some kind of reference. So I labeled this A, B, C, and I labeled this X, Y, Z. So I try to always put my sides, at least for my first one, in ABC order, just because my brain is weird like this. So I'm going to start with triangle A, B, C. And it is congruent to what? Well, if I go from A to B, what mark, how many segment markings, congruent markings are on that side? 1. So I have to use the same side that has one congruent marking on it. What's the name of that side? Yeah, YZ. And then if I go to the next marking, BC, that has 2 markings on it, I have to go to the one that has 2 markings. And that's ZX. So that tells me the order to go. Triangle ABC is congruent to triangle YZX. ABC is congruent to triangle YZX. I want to talk about this triangle because a lot of times we miss something like this. And it's just because we don't have a geometry class here in this state, and we just don't think about this. But if I were to think about this triangle right here, if I were to color this one all red, I don't know why that's doing that. And then I were to color the other triangle green. What could you tell me about the two sides that touch each other, the green and the red side? Those two sides that touch each other. What could you say about them? They're the same. They're congruent to each other, right? Is it marked congruent? It's not, but I know that if two sides, like the red triangle is made by this middle piece, and so is the green triangle, right? They share a common side. Well, that means that that side is congruent to itself. So I have side. You guys see this? One side, like 1 mark, 2 marks, 3 marks, 1 mark, 2 marks, 3 marks. So just watch for that side. So I'm going to just say that one side is shared between two triangles. One side is shared between two triangles. So we say that they have a common side. They have a common side. So we use the side postulate. But there is another postulate that we use to prove that triangles are congruent to each other. And it's the side angle side. If two sides and the included angle of one triangle are congruent, if two angles and the included angle, two sides in the included angle of one triangle are congruent to two sides in the included angle of the second triangle, then the triangles are congruent. So I'm trying to shrink that up so I can see the whole picture. So I'm going to label these just because, again, I think that we need some labels. So I'm going to call this A, B, C, and I'm going to call this J, K, L. So what is this angle right here? What is the measure of it? Yeah, it's 90 degrees. Do you guys see that 90-degree marking right there? This is also 90 degrees. So what can you tell me about angle B and angle K? They're equal to each other. They have the same measure. So 1, 2, 3 markings, 2 markings. The angle is in between the two sides. In between the two sides. That's why it's called the included angle. 1, 2, 3 markings, 2 markings. So we can say that triangle ABC is congruent to triangle JKL by side angle side. Side angle side. So I'm going to go to the next one. I'm going to go to the next triangle and notice that we have a congruent angle here and a congruent angle here. Do you guys see that? We have 2 side markings, congruent to 2 side markings right here. Is there a way to use side angle side to prove that these triangles are congruent to each other? What, Aiden? I thought you shook your head yes. No. Oh, no? Okay. Does anyone see a common side between the two triangles? Which one, Dakota? Yeah, this one in the middle, this is a common side. Do you guys see this? Both triangles share that side. That means it's congruent to itself. Now I have side, angle, side, side, angle, side. So these two triangles are congruent by side, angle, side as well. Again, notice that the angle is between the two sides. It has to be between. It's called the included angle. It's the angle that's included between the two congruent sides. It's the included angle. So first question says, draw a picture of two triangles that are congruent by side, side, side. Well, I'm going to draw a right triangle, or like what appears to be a right triangle. How do I show that these are congruent to each other by side, side, side? Well, this side is congruent to that side. They each have one angle mark. What should I do next? Huh? What other two sides have to be congruent to each other? The top two, hypotenuse, or hypotenize. Okay. And then what else? Yeah, the base. 1, 2, 3. 1, 2, 3. So I have 3 sides of one triangle congruent to 3 sides of another triangle, right? Does that make sense? That's how we draw that. Okay. Our next one is asking us to draw a picture of two triangles that are congruent by side, angle, side. So I'm going to try to rearrange the way that my right triangle is drawn. So side, angle, side. So if I marked this side congruent to this side and this side congruent to that side, where does the angle have to be? The angle has to be in between the two congruent sides. So where does the angle have to be? The bottom right side or the left side? Yeah, the bottom left. That congruent angle has to be in between your two congruent sides. So it's got to be right here. Say again. Because I only have two sides that I'm marking. So the only time that I put 3 marks is if I'm marking 3 different sides. Does that make sense? Okay, good question. So sometimes we're going to have a question that says, hey, these two triangles are congruent to each other by side, angle, side, or side, side, side. What else needs to be marked congruent to prove that? So you basically have to figure out what part is missing, right? Everybody pick their heads up. You guys are getting sleepy. Heads up. Let's go. Vanessa, head up. What additional piece of information would be needed to prove that this triangle is congruent by side, angle, side? So what angle lies in between these two congruent sides right here? And what angle lies in between these two congruent sides? Those two lines make an angle. They form an angle. What angle do those two segments form on the first triangle? What is this right here? Do you guys see that this forms an angle right here? Like these two lines make an angle right here. Do you see that? So this is the included angle. It's named angle L, and it has to be marked congruent to what? Angle L has to be congruent to angle H. Good job. They have to be marked congruent to each other. If they're not, you could not prove those two triangles congruent by side, angle, side. Okay? It's asking you what is missing. All right. So this is asking you to determine which postulate can you use, side, angle, side, or side, 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 or sometimes none. Sometimes you can't use anything, right? So it's not possible. So let's look at this first triangle. Now, the thing with this is we're not just using things that we learned today. We're using some things that we know about angles. So I have this side congruent to this side. What do I know about this angle and this angle? Why? What kind of angles are those? Congruent is a measurement of the angles. It's not a type of angle. What type of angles are those? Two lines that intersect. Nope. There's no transversal. Yeah, these are vertical angles. These are vertical angles. And we know that vertical angles are always congruent. Okay, so do you have enough information to show that one triangle is congruent to the other? Do you have side, 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 or side, angle, side? No, not possible. You don't have enough information. Okay, so this one is not possible. Let's look at example number 5. So example number 5, you have a side congruent to a side. You have another side congruent to another side. And you have this right angle right here. So what method could you say that those two triangles are, what method could you use, or what postulate would you use to say that those two triangles are congruent? Side, angle, side. Well, what do I know? Say again. SSS. I agree with this. I agree with Aiden. Aiden said SSS. Because what do we know about this side right here? What can we say about this side right here? It's congruent to itself because it's the shared side or the common side. So I have 1, 2, 3, 1, 2, 3. So I could say it's congruent by side, side, side. And once I see that that has a common congruent side, then, Quali, I can use side, angle, side. Side, angle, side. I have to, you can't use side, angle, side. I'm going to draw on this. Without this marked, you tried to use side, angle, side. And if these two sides are congruent to each other and you want to use side, angle, side, you would need this angle to be congruent. Do you see that? Because it has to be in between the two congruent sides. Does that make sense? But once you realize that, wow, this is congruent to itself because it's a common side, then you could use side, angle, side. So it could be both of them as long as you realize that you have a common side. Okay. You have to realize that it's got a common side first. What about number 5? What about number 5? Do you have a common side? That's the first thing I would look at every time. Yes, I do. I'm going to put 3 marks on it. So what postulate can I use to say that one triangle is congruent to the other? Side, side, side. I have 3 sides marked congruent. Okay. 3 sides marked congruent. All right. So state if the 2 triangles are congruent, and if they are, tell me how you know. Let's look at this first pair, number 1. What do we know about the common side? What do we know about this shared side? They're congruent to each other, so put a mark on it. It's congruent to itself. So I have a side and an angle and a side, and I have a side and an angle and a side. So how are those 2 triangles congruent to each other? By side, angle, side. Let's look at this next example. Watch out, I'm trying to trick you. Do you have a common side? Yeah, this one right here, common side. It's right in the middle. So do both triangles follow the side, angle, side pattern? No, this is side, angle, side. But this side is not side, angle, side. So you have side, angle, side for this top triangle. But this bottom triangle does not follow that pattern. Right? Do you guys see that? So this one is good, but this one does not. So this is a no, not possible. Do you see why? Okay, because when I separated them, I tried to show you that the angle is not in between the 2 congruent sides. That's a tricky one. What about example number 3? Yes or no? By what method? Side, side, angle, side. The congruent angle is nestled in between the 2 congruent sides. Do you see it? What about example number 4? Not possible. Explain why. Yeah, good job. On the right triangle, on this triangle right here, the triangle on the right side, if this was going to be congruent by side, angle, side, the congruent angle would have to be right here, and it's not. It's not in the right spot, so I can't use side, angle, side. Okay? Do we see that? Okay, number 5. What method? Good job. I'm going to put 3 marks on here. Quali, I'm putting 3 marks because I already have 2 sides marked with 1 and 2 sides marked with 2. So 3 is the next one. And yes, SSS. What about example number 6? SSS. And I don't have a side with 1 mark, so I'm going to give that 1. I'm going to mark it SSS. What about example number 7? Good job. It's already marked for you. You don't have to do anything. What about example number 8? Do we have a common side? We do have a common side right here. So I have side, angle, side, side, angle, side. So SAS, do you guys see that? God bless you. Okay. What about example number 9? Not possible. Yeah, even though they share a common side, this top triangle follows the side, angle, side pattern, but the bottom triangle does not. It follows the side, side, angle, and side, 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 angle, or angle, side, side spells booty. There is no booty postulate. Okay. Oh, yep. No booty postulate. Okay. What about this next one? Yeah, good job. Does that make sense? Do you guys feel okay about that? A little bit? So on this next one, you're going to tell me what's missing. You're going to use either side, 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 or side, angle, side, and you're going to tell me what's missing. So example number 11. Example number 11. If I wanted to prove triangle HIJ congruent to triangle GIE, what would I need? What's missing? And I'm trying to prove it with side, angle, side. So do we have a pair of congruent sides? Okay. Do we have a pair of congruent angles? Yes. What are they? Angle JIH and angle G. Good job. Why are those congruent to each other, Jacob? What kind of angles are there? Vertical. Yeah, those are vertical angles. And remember that vertical angles are always congruent. Yeah, good job. So there's my side angle. What's the missing side? JI and EI, right? Segment JI has to be congruent to segment EI. Do we see why that is? Do we see how the angle is, the congruent angle is in between the two congruent sides? That's how we choose that side. Okay. I want to do another side angle side. I have one side congruent to one side, and I have another side congruent to another side. So what am I missing there in the SAS? Missing the angle. Where does the angle have to be? Yeah, in between the 1 mark and the 2 mark, which is angle L and angle what? And angle H. Do you see that? Angle L has to be congruent to angle H. What about example number 13? Why? Why is it DX and YZ? What do you have marked that I don't have marked, Jacob? What am I missing? What's common side? What's that thing in the middle called? It's just a segment. What's it called? Segment what? Well, what are the 2 endpoints? They're letters. What are the 2 letters? You're not done? Yeah. So segment XZ is congruent to itself because it's the common side, right? So what are we missing? We're missing this congruent to that. Good job, Jacob. Number 14. Number 14. What are we missing? Well, we're missing a side. RT has to be congruent to XZ. What about number 15? What's missing? We have side and we have angle. The angles with are the sides with 2 marks on it? What are those sides? Yep. WU. So do you see what this picture looks like when I put it on there? Make the other picture look like this. Side, angle, side. 1 mark, angle, 2 mark. 1 mark, good job. Awesome. Okay. What about number 16? Side, side, side. What do you got, Dylan? Oh, Chandler, go ahead. Yeah, GE has to be congruent to side WY. And those are segments. That's why I put that bar over the top of it. Good job. Dylan, I'm going on to you for number 17, okay? Number 17, we're doing side, angle, side. Tell me what you know about the common side. And say it by its name. Yeah, side GF or side FG is congruent to itself. So what angle are you missing? Don't we need to have this angle congruent to this angle? Okay, so this one's a tricky one. Because all up to this point, we've just been calling angles angle A, angle B, angle C, right? But because F is shared by both sides, you have to name it the way that it's written. Angle E, F, G, and angle Q, F, G. So you need angle E, F, G congruent to angle Q, F, G. Last one. Rustin, what angle do you know to be congruent and why? Even though there's nothing marked. Yep. So it's angle DSB. Do you guys see how I named that? Has to be congruent to angle TSR. Why do I know that those are congruent to each other? What kind of angles are those? Those are vertical angles. And what do we know about vertical angles? Yeah. So we have our side and our angle. What side are we missing? If we follow it around. Side, angle, side. Side, angle, side. What are we missing? On the top triangle, what side nestles that angle, completes that angle? Yep, segment DS. Good job. And on the bottom, what side? So if D started at the outside and S is the vertex or the middle, how should you name that other side? Start at TS. Good job. Okay. All right. So your guys' homework is pages 25 through 28, and you're going to do the exact same thing that we just did. 25 through 20.